Good day, everyone. We are here to present to you our Arduino project video presentation. I would like you to introduce to you our Group 5, with a group name Brocode, together with my members, Mark Allen Hortilano, Daniel Monteroso, RB Labitad, Maria Risa Mejia, and Nikki Zane Canzon.
Project 13, Motor Fan, an Arduino-based system designed to control the operation of a fan using a bottom and a relay. This project allowed the user to control a fan with the bottom using the relay to switch the fan on or off while managing signal noise using the bouncing techniques.
The materials we will be using are a DF Arduino Uno prototype shield with breadboard, 9 pieces jumper M2M, 1 relay, 2 pieces resistor 220R, 1 5mm LED, 1 fan blade and 130 motor and 1 push button.
Connect the button with the 220 resistor pull down resistor in order to hold the logic signal near 0 volts when the button is disconnected. The relay has 6 pins. Pin 1 and 2 on the relay are input signals and are separately connected to digital pin 3 and GND on the Arduino. Pin 3, 4 and 5 and 6 on the relay are the output signals, but we will only use pin 4 and pin 6 at this time. A relay is similar to a push button which has 2 connections as well.
After that, you will see our group preparing for this project. And for the code, this code is an Arduino program to control a fan using a button and a relay. The relay will toggle turn on or off each time the button is pressed. So for the variables, we declare button pin that set the digital pin for the button input pin 2. And for the relay pin, we set the digital pin for the relay control pin 3. We also declare relay state that holds the current state of the relay, which is high is equal to off initially. We also declare button state that store the current reading of the button state, press or not. We also declare last button state that store the previous state of the button to detect changes. We also declare last debounce time that record the last time the button state change, helping filter out noise. Lastly, we declare debounce delay that set a delay 50 ms to debounce the button signal, eliminating unintended toggles. For the setup function, we declare button pin as an input so the Arduino can detect button presses. We also declare relay pin as an output to control the relay. We declare digital write relay pin relay state that set the relay to its initial high and is equal to off. For the loop function continuously checks for button state changes and toggles the relay when the button is pressed. Reading is equal to digital read button pin reads the button current state. Number 2, if reading is equal or not last button state, we detect a change in button state, and if true, we set the last debounce time to the current time with milliseconds, the built-in function that returns the time since the program started. Inside of the debounce check, if reading is equal or not button state, meaning the button state is stable. We declare also digital write relay pin relay state that applies the toggle relay state turning the fan on and off. Lastly, we declare last button state is equal to reading, updates last button state to prepare for the next loop. This code effectively turns the fan on or off each time the button is pressed, using the bounce logic to filter out the accident triggers. After that, we will see the final output. And for the challenge, our challenge titled Interactive RGB LED Control with Relay and Smooth Color Transition. This project is an interactive RGB LED system controlled by a button and relay, allowing smooth color transition.
So for this challenge, the materials we will be using are leaf Arduino Uno, prototype shield with breadboard, 13 pieces jumper M2M, 1 relay, 4 pieces resistor 220R, 1 RGB LED, 1 fan blade and 130 motor, and 1 push button.
For the button, connect one leg of the button to digital pin 2 on the Arduino. Connect the other leg of the button to GND on the Arduino. Add a pull-up resistor. 10K resistor is recommended between digital pin 2 and 5B to stabilize the input signal. And the relay, connect the relay pin to digital pin 3 on the Arduino to relays input pin IN or SIG. Connect the relays VCC to 5B on the Arduino. Connect the relays GND to GND on the Arduino. Relay load wiring. Depending on your relay and device, connect the device, a light or motor. To the relays normally open, NO, and common COM terminals. And for the RGB LED, connect the red pin of the Arduino RGB LED to digital pin 9. The red pin on the Arduino through a resistor 330R resistor is recommended. Connect the green pin of the RGB LED to digital pin 10. The green pin through a resistor. Connect the blue pin of the RGB LED to digital pin 11. The blue pin through a resistor. Connect the common cathode for common cathode RGB LEDs or anode for common anode RGB LEDs to GND common cathode type or 5B common anode type. The code assumes a common cathode type LED where each color is controlled by grounding each pin. Adjust the code for a common anode type by inverting the PWM values for each color. And for the power supply, use the Arduino's 5B and GND pins to power the circuit.
And for the code, this Arduino code controls a fan and an RGB LED, allowing the fan to toggle on and off with a button press while the LED cycles smoothly through colors when the fan is running. For the variable, we declare button pin that set up to pin 2, relay pin that set up to pin 3, relay state that holds the relay current state, high is equal to off. We also declare button state that store the button current state, last button state, last debounce time, and also the bounce delay. For the RGB LED control, we declare red pin, green pin, and blue pin components for the RGB LED allowing color mixing. We also declare is running that tracks whether the fan and color cycling are active. We also declare transition delay that controls the speed of the color transition for a smooth effect. For the setup function, we config button pin as an input to detect button press. We also config relay pin as an output to control the relay. Lastly, we set the initial state of the relay off using digital write, relay pin, and relay state. For the loop function, we declare the bouncing button presses. Reading is equal to the digital read button pin that read the current state of the button. If the button state reading differs from last button state, last debounce time is set to the current time. If the button state has remained stable for longer than the bounce delay, it is treated as valid press. If button state change to high, the button toggles relay state and is running. We also declare relay state, digital write relay pin, set the relay according to relay state. For the color cycling, if is running is true, smooth cycle colors is called to initiate the LED color transition. Otherwise, turn the LED off. For the smooth cycle color function, we use smooth transition to gradually shift from one color to another. Transition occur in order red, yellow, green, cyan, blue, magenta, and red. If button is pressed during any transition, smooth transition stop, turning off the LED. For the setup color function, we set color, enter the red value, int green value, and int blue value to set the color of the RGB LED by adjusting each color intensity. Lastly, we declare analog write that adjusts the brightness for each color component based on the provide values. After that, you will see the final output. That's all. Thank you.